Hey guys, welcome back to the channel. This video is going to be a little different from the previous videos in this playlist. Instead of introducing a new prompting technique, this video is meant to act as a summary and conclusion to everything we have learned throughout this prompt engineering series. Over the last few videos, we have explored many different prompting techniques, and one thing should be clear. There is no single prompting technique that works best for every problem. Different tasks require different approaches, and understanding when to use each technique is often more important than simply using the most advanced method available. So, in this video, we will build a simple framework to help you decide which prompting technique to use depending on the type of problem you are trying to solve. So, as we move from simple questions to complex reasoning, tool use, and complete workflows, the requirements from our language model also change. A simple factual question may only require a basic prompt. A mathematical problem may require explicit reasoning. A task involving external information may require tools or retrieval, and large real-world applications often require multiple prompts working together in a workflow. This is why there is no universally best prompting technique. The best technique is simply the one that matches the problem you are trying to solve. So, for example, if the task we need to perform or solve is very simple and the model is very familiar with it, so generally we don't require any examples for it. This includes tasks like translation or summarization or basic question answering. For these, the best possible approach is zero shot prompting, where you need to keep the instructions simple and clear. But if you want to guide the model to output in a particular format, then you require to help the model learn patterns and improve its consistency, then providing a few examples of how exactly you want the output is better. So in such cases, few shot prompting works pretty well. Now, when you have a complex task or question which you need to break down into simpler steps, to help improve the accuracy of the model. So for such cases, chain of thought prompting is required. It's very useful for tasks which involve tracking, maths, logic building, or puzzles. Now, if you even want a more accurate or better solution than chain of thought prompting, then we use self-consistency. It reduces the mistakes as compared to chain of thought prompting. The answers are more reliable and more accurate, even though this takes a little bit more time than chain of thought prompting. Now, for tasks like planning or for games like chess, where you want to explore multiple solutions and then select the best one among them, for such cases where exploration is required, methods such as tree of thoughts promptings work pretty well. Now, suppose you want to ask the model a question where you require external tools because the model might not be up to date with the current information. So, for this, you need to interact with other APIs or databases like Wikipedia API, etc. So, for such cases, you require React prompting where you ask the Wikipedia or any other source for the up to date information to answer the question correctly. So, some tasks are useful for improving performance in specific situations, like prompt chaining. It's useful when the task can be broken into multiple stages, such as research, outline, drafting, reviewing, etc., and refining, which can't be done in a single prompt. So, for such cases, prompt chaining is pretty useful. A generated knowledge prompting is useful when additional background information can improve reasoning, and it also helps in reducing hallucinations. Now, least most prompting is another method which works well when a difficult problem needs to be decomposed into smaller subproblems and solved. There is also the method of reflection prompting, which is useful when you need to learn from your mistakes and improve in future attempts. These techniques are more specialized but can be extremely powerful when applied in the right context. So, this slide is basically the summary of the entire playlist in a single decision framework. So, like if the task is simple and straightforward, we can use zero shot prompting. If some examples are needed to guide in a particular format, we can use few shot prompting. If reasoning is required or the task is a bit more complex, we can use chain of thought prompting. If you want even more reasoning accuracy or reliability in chain of thought prompting, use self consistency. If we want exploration and planning, then we can use tree of thoughts. If external tools are required to keep the information up to date, we use React. If the problem involves workflows or specialized situations, techniques such as prompt chaining, generated knowledge, least most, and reflection become useful depending upon the tasks. So, of course, in practice, these techniques are often combined together rather than using them individually. So that's going to be it from my side for this video. In this video, we summarize the entire prompt engineering playlist and built a framework for choosing the right prompting technique for different problems. With this video, we officially come to the end of our prompt engineering playlist. I hope this series helped you build a strong understanding of prompt engineering and model prompting methods used with LLMs. Obviously, prompt engineering is an active area of research and new techniques are continuously coming up. So, if there are any prompting methods or topics from the literature that you would like me to cover in more detail, make sure to let me know in the comments below, and I may make dedicated videos on them in the future. As always, if you found this video helpful, make sure to like, comment, and subscribe, and let me know how I can improve further. Thank you guys for watching the entire video.